Alright guys, today we're going to start talking about forces and Newton's law. Today we'll focus on what is a force and Newton's first law. So first of all, a force is any push or pull on an object, and we measure forces in newtons. And a newton is the same thing as 1 kilogram times meter per second squared. So essentially then what a newton is the amount of force required to make a 1 kilogram mass accelerate at 1 meters per second squared. And it's also approximately the same thing as a quarter of a pound. So a newton is about a quarter of a pound. It's slightly less than that. Okay? Forces have magnitude and direction, which means that forces are vectors. So we could say that I'm pulling with a force of 200 newtons up, or 500 newtons to the right. So forces have both magnitude and direction. They are vectors. So when we're talking about forces, there are essentially two main types of forces. And the first one is called a contact force. And as the name implies, a contact force is one that requires some sort of physical contact between two objects. Like if you kicked something, pushed something, hit something, that would be a contact force. And the main contact forces we'll be using throughout this year are the normal force, tension, and friction. But there will be others as well. And then we also have field forces. And field forces are forces that do not require physical contact between two objects. And the only one we'll be using first semester is gravity. So gravity is one of the 4 fundamental field forces. And of course, when you're talking about gravitational force on an object near an Earth's surface, then we typically call that weight. And we'll talk more about weight in a little while. Alright, second, we also have what's called the weak nuclear force, which is important when we're talking about interactions between particles in the nucleus. So we're not worried about that for right now. We also have electromagnetic forces, which is important when we're talking about forces between charged objects or magnets, which we're not worried about right now. And then we also have the strong nuclear force, which is also important when we're dealing with forces between particles in the nucleus, but we're not worried about that right now. In fact, the entire first semester, the only one of these we'll use is gravity. The other 3 we'll get into next semester. So for the next week, we're going to be focusing on Newton's first law. And Newton's first law says that an object at rest remains at rest, and an object in motion remains in motion with constant velocity as long as no net external force acts upon it. So basically what we're saying is if we have an object that's sitting still and no net external force acts on it, then it will keep sitting still. And if we have an object that's moving and no net external force is acting on it, it will keep moving with a constant velocity. In other words, it will keep moving at the same speed and it will move in a straight line. So we say no net external force because it is impossible for an object to have no forces acting on it. No matter where we put an object, it's always going to have gravity acting upon it and may have some other forces acting on it as well. So, how do we get no net external force? We'll talk about that in just a second. Second of all, Newton's first law is often called the law of inertia. Inertia is the tendency of an object or of matter to maintain its state of motion. And that's what Newton's first law says. If there's no net external force acting on an object, it will maintain its state of motion. So it's called the law of inertia. And this law describes an object that we call in equilibrium. So if an object is in equilibrium, we can tell because it will either be at rest or moving at a constant velocity. And if it's at rest or moving with a constant velocity, that means no net external force acts upon it. So now let's talk about what it means for there to be no net external force on an object. So how can net external force equal zero? Well, first of all, for net external force to equal zero, there has to be at least two forces acting on an object. If we only have one force acting on an object, then that one force will be the net external force. So for example, if we're talking about a free fall problem, the net external force on an object would be the weight of the object going straight down, and there's nothing counteracting that. So we have to have at least two. So if we have no net external force in the vertical direction, then what we're saying is that the net force in the y direction equals zero. Well, for net force in the y direction to equal zero, then that must mean that all of the forces that are acting up minus all of the forces acting down equals zero. Or another way to say that is that the forces up equal the forces down. And if that's true, then the net external force in the y direction will equal zero. Now we can also have forces in the horizontal direction. And if we have forces in the horizontal direction, then we're looking for net force in the x direction to equal zero. And for the net forces in the x direction to equal zero, then the forces to the right minus the forces to the left have to equal zero. Or another way of saying that is the forces to the right have to equal the forces to the left. So think of this like tug of war. If both teams are pulling with exactly the same force, then we end up with no movement, because we would say that that rope that they're both pulling on is in equilibrium. So for the next several screencasts, what we're going to do is we're going to apply these concepts to objects that are in equilibrium. So we're going to look at objects that are either at rest or moving with a constant velocity, explain that the net forces on the objects must equal zero, and that's going to allow us to set up a system of equations to solve for unknown forces.